Welcome to episode 16 of CipherVibe's end-to-end cloud security architecture course. Data loss prevention reduces the chance that sensitive information is copied, exposed, or moved outside approved boundaries. It works best when classification, access control, network controls, and business workflows already provide usable context. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. DLP consumes labels and discovery findings, then applies guardrails at endpoints, SaaS services, APIs, databases, and cloud storage. It also supplies high-value signals to detection, investigation, and regulatory response. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is map-approved data movement. Document which users, systems, partners, and destinations legitimately receive sensitive data and through which approved channels. DLP policy should protect those workflows while making unapproved transfers, bulk exports, personal destinations, and unusual cross-boundary movement visible. The second building block is minimize and transform sensitive values. Use tokenization, masking, anonymization, or synthetic data when downstream systems do not need the original value. Choose the method based on the task, preserve necessary utility, and assess re-identification risk rather than assuming data is safe because obvious identifiers were removed. The third building block is monitor high-risk access and exports. Collect database, object store, SaaS, and API events for sensitive reads, downloads, exports, sharing changes, and permission changes. Combine volume, destination, identity, time, data class, and baseline behavior to prioritize investigation without drowning operators in routine alerts. The fourth building block is use prevention carefully. Start in monitor or warn mode for complex workflows, block high-confidence prohibited transfers, explain safe alternatives to users, and keep a governed emergency override. The goal is durable risk reduction, not a bypass culture caused by controls that prevent legitimate work. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. An effective DLP pattern identifies sensitive information, permits named business flows, observes risky use across data services, and blocks only the paths where policy and context make the decision reliable. Implement this layer in a sequence that preserves evidence and limits blast radius. First, define sensitive classes and approved destination patterns. Second, deploy discovery and activity monitoring for priority stores. Third, use tokenization or masking in lower trust workflows. Fourth, pilot DLP policies in monitor and user guidance modes. Fifth, enforce high-confidence blocks with exception and response paths. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, blocking every occurrence of a pattern without business context. Second, relying on DLP while users retain excessive data access. Third, ignoring data exports, analytics tools, and third-party integrations. Fourth, treating anonymization as permanent when data can be re-identified. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, test approved and prohibited transfer scenarios with synthetic data. Second, measure sensitive data discovery, alert fidelity, and exception expiry. Third, review database and object store export evidence. Fourth, exercise the response to a suspected bulk data exfiltration test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, design a DLP policy for a fictional customer support team that needs to share selected records with an approved vendor. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that data loss prevention becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.